Hello and welcome everybody, this is Roland from graphicinmotion.com and it is tutorial time again. So let's check out what we are going to create together today. In this tutorial I want to give you a basic introduction into the Vellum Hair workflow. We will use some of the very powerful Houdini hair tools together with the Vellum simulation to create this little scene that you see here. So we have these nice hairs here, or this fur, and we have our rubber toy moving through it and interacting with the fur. Along the way I will show you the most important parameters that are important to create simulations, to Arts Direct simulations like this. I will show you a few problems that you may run into when working with Vellum hair. And we'll also talk a little bit about how preparing hair for rendering. If you want to dive deeper into these techniques, then I would recommend that you check out my Patreon, because there I will release more in-depth tutorials about Vellum hair, for example, like applying a fur to soft body simulations and all that stuff. So if you're interested in that, then please check out Patreon. But for now, let's jump right into the tutorial and let's get started. As a first step, let's add in a geometry node. And I will call this my hair sim and dive inside there. Then I create a circle. This will be my base geometry. And I will grow my hair on this circle, and I will just lay it flat in my scene and increase the divisions a little bit so that it is nice and round. Now, when you're creating a hair simulation with the Vellum, the usual workflow is that you create some guide geometry and you simulate the guide geometry, and then you add more hair into it. To create guide geometry for hair, you usually use something like a line. So the standard setup would be that you add in a line here, and then you add some points with a scatter node onto your object, like so. And then you can just do a copy to points, as we are all familiar with that, and just copy this in here. And then you would have a bunch of lines that you can then use as guides, and you can simulate these as Vellum hairs. But there is a better option, so let's delete that. And Houdini has really cool hair tools. And one tool that's really good, or one node, is the hair generate node. We can use this and plug it directly into our source. And the hair generate node does exactly the same as I showed you. It scatters points and then it copies, or it adds some lines onto these points. Right now these lines are a little bit short, so let's increase the length down here to 1. And you also can see that these are pointing downwards. This has to do with the normals of my circle. So what I could do here is just reverse the normals of my circle, because I want these to stand up straight. I want to create something like a field of grass, whatever, or some underwater plants that are nicely moving with some wind. So I want these to stand up straight. Now, if we take a look at the points, you see that these are also subdivided. This is of course important when you want to simulate some bending. And you can specify this here with the segments. In my case, I do not want that many guides, so I do not need that many guides, and I can increase the segments a bit. So let's turn down the guides first of all. And I want to use something like maybe 200 density. This will generate how many? About 600 primitives. Yeah, that should be fine. And we can increase the segments a bit so that the bending is a little bit more accurate. And I set it to 12. And this should still be, or still simulate quite fast. So this is not the final hair that I will render. This is really just, these are just guides I'm working with. Now, to turn these into Vellum hairs, we need a Vellum configure hair node. This is a Vellum constraint node that is set up for hair simulations. And of course we need a Vellum solver. So let's put this in as well. And you can hold down J and just drag or draw a line between these, and this will link up. This is a trick that I recently discovered, and it's pretty handy actually. So right now, if you run the simulation, you know what's happening. These are just falling down because of the gravity in our scene. So we have to create some pinpoints, as always with these simulations. And for hair, it's good if you create these with a group expression node. So let me add in a group expression node. Because with the group expression node, it's very simple to select only the first points on a primitive. And you can just do that by changing the group type to point and then choosing one of these Vexpression presets that's called first point of primitive. And if you do that and take a look here, then we have the first points here selected. and somehow it is not shown in the viewport now, or probably because this is turned on. Let me take a quick look here. Yeah, now we can see it. Here we see the points that are now selected, and I can call this group pin. On the Vellum Hair constraints, we have these pin points, and here we can specify this group. Now these are pinned, and as we would expect, if we now run the simulation, after a while, gravity will take over, the hair will fall down, but our points will stay in place and they will not fall down. Very good. Now, let's add in some forces. So in the Vellum solver, let's dive in there and let's add in a pop force just to create some nice wind here. And I want to set the amplitude to 1.5, the swirl size maybe a bit higher to 2.5, but I want to turn down the roughness to 0.2. If I take a look at the guides, you see what I'm creating here, just a smooth turbulent field that will wiggle around my hair. If I run the simulation now, they will fall down faster because as soon as the force is pushing them around, the gravity will drag them down. And this has to do because our hair right now, if we take a look at the settings, are pretty bendy. So the bend stiffness is quite low. If you want your hair to stand up straight, you have a few options. The first option is that you just change the bend stiffness. That's something that you can of course do. So let's change it quite a bit, make them quite stiff to 0.1. And you see right now, these are not behaving like hair anymore. These are now behaving more like maybe wheat in the wind, a wheat field, or like some bristles of a brush or whatever this is called. So you can do something like this. And of course, the other option would be that you leave them very bendy and just turn off the forces here, the gravity, and then you can create something like an underwater feeling. As you can see here, now they are very bendy and they are bended around quite a bit by our forces. So this is also something that's pretty cool. And I want to go more in this direction. So I really like this movement. It's very organic and very cool. But I will add a little bit of an upward wind. So just add the force along the y-axis. So maybe 1 is enough. And you will see what this will do. Now the wind will just look a little bit more natural and they will not bend down that far. So let's say this is the simulation that I want to achieve. And I think it really looks quite nice. Like, as I said, a plant underwater. So the bend stiffness is one of the most important attributes here. And of course, also the stretch stiffness, which is set very high. Now, if you set this very low, then these will get like rubber bands and they will change their length. As you can see here, now with the forces, these will bend. And yeah, this can also be quite a nice effect if you want to generate something like this, like rubber bands in the wind. In my case, I don't want that, so I will go to my stretch stiffness and set it up high again. Another very important setting for Vellum hairs are up here, and here we have the density, which is actually the mass, and we have the edge length scale, that's actually the thickness. The density is important when you create something like collisions. So the density by default is set quite low, and yeah, that's logic because it is usually hair is very light. If you want to create something like rope, and Vellum hair are really great to simulate ropes, then you may have to increase this. Also, if you're doing something like collisions, like an object is dropping into your hair, you may have to take a look a little bit on this value and control your masses. So on the one hand, you have to control the mass of the object. On the other hand, you want to control the mass of your hair because these two are interacting and they can cause some problems. So always keep an eye on your density values here. If you're simulating something as we do here, something very light and very bendy, then it's fine to leave it at 0.001. The other thing that is very important is the thickness. And if I visualize this for a moment, you will see that these spheres are actually the thickness or representing the thickness that is calculated by collisions. So we have no real collisions now. Of course, they are colliding with each other, but it's very difficult to see. But let me bring in a collision object quickly. So I will just add in a rubber toy here and create a quick animation with this rubber toy. So let's add a transform in here. And I just want to scale it down. It's way too big, so 0. Maybe 7, yeah, something like that. Maybe even further. Let's scale it down a bit smaller. And let's set up a quick simulation or animation, something like that, so that it travels through our field here. I will turn off the solver for a moment and create a very quick animation. So let's just create a keyframe here, move forward 125 frames, and until here, new keyframe, and that's it. So now we have this kind of animation, as you can see. And if we plug this into our collision geometry stream, then of course this will now work. So let's take a look at that. Let's go to our Vellum solver and let's see what this will do. And nothing, because I forgot to turn on my solver. So let's turn on the solver. And now let's run the simulation again. And I have some problems here. I think that this is a viewport problem. So go to labs and reset viewport. Yeah, now it works. Okay, so let's run the simulation again. And now you see it's colliding nicely with our rubber toy. And if we take a close look here, it's a bit hard to see. But of course, Vellum calculates, as I said, the thickness that is specified here for the collisions. Now we can make this a little bit more obvious by adding in some geometry here. So let's do that quickly. We can add in a sweep node here after our solver. You have basically two options to add geometry to your hair simulations. You can either do it with a sweep or you can also do it with a polywire. It really depends what you want. They're both pretty similar. In the sweep, you just select a round tube. And if we activate or if we change the radius to 1, then it will take over exactly the value that is put in here. So if I set this down to 0.1 now, you will see, after I reset the simulation, of course, that also the thickness of our geometry changes. So this has an influence here. These are linked through the p-scale attribute. Now there's one problem when working with these sweeps directly on the output of a Vellum hair simulation. And as you see here on the top here, these circles or these lines are a little bit bending in a strange way. And this can lead to problems, especially if you want to use these caps here. There are caps that you can use. And usually these should be nice and round. But you see, because of these strange behaviors, we get very, very strange artifacts. And that's really not good. So when I tried to solve it, I thought it definitely has something to do with one of these many, many attributes that are created by the Vellum simulation. And it actually is so. I was not able to isolate which one it was. So maybe it's a combination of a few of these attributes. But the solution is to just add in a clean node, add it in here, delete all the attributes except one. And that's the p-scale. Of course, if you have something like a curve view or whatever, if you added another attribute that you need, then you have to exclude that also here. But you see, by just removing everything except the p-scale, we get the behavior that we would expect of this sweep now. So that's an option. So if you want to create something like this, you can use the sweep, and it has also this very cool option that you can manipulate the thickness along the length of this, so you can create quite interesting things, maybe something like that, and creating some underwater plants, That's something that you can do with the sweep. And as I said, you can do a similar thing with the polywire. So if we try this out here, let's go to the polywire. By default, the polywire only has a radius setting, so you can just change it manually here. But you can also use an attribute, so you can change it to attribute, and if it uses the p-scale, then it works exactly the same as the sweep. It just will use the thickness that is specified right here. You see that by default, this is only creating these squares, so we have to increase the division height quite a bit, and then we will get these round tubes, and everything is pretty similar. By default, it also adds UVs. You can do the same here on the sweep. If you want to go to UVs and compute UVs, then you will also get a UV layout. So this is just a quick, very quick rundown of how you can add geometry to these simulations. But we actually do not want this, because I want to create a hair simulation. So I want to add in way more hairs here. So how can we do that? Let's say that we are satisfied with our simulation. So let's run the simulation, and you see that it is nicely colliding, there are no artifacts. And yeah, one more thing before I save this to disk. There is a problem that you can run into if you are working with very thin hair. So if you want to simulate hair that are really thin, for example, something like 0.05, and if we take a look here at these, that's, oops, I made a mistake, 0.05. Let's delete the channels. You see these spheres now, they are quite thin. They are still not that thin as real hair, but they are way thinner. And if you want to simulate these kind of collisions, sometimes you run into problems. So let's take a look whether Houdini is able to handle it right now without any intersections. It of course depends on the speed of your collision object, but you can already see that some of them get stuck. So you see what's happening here. And this is definitely not a good solve. Now, if you run into these problems, there are a few options that you have to fix that. The first option is, of course, as always, to increase the substeps, but I would not do that right as a first step. Try to increase the collision passes instead. You can set them to 30. This will probably not be enough in our case. Let's take a look. Sometimes this is already enough. And I'm not sure. Let's see. No, you see some of them are still intersecting, so you can increase this slightly to 50, maybe to 100. The collision passes will make a simulation also slower, but not that bad as substeps. And the advantage is that it does not really change the behavior of the constraints. And if you add more substeps, you add more constraints, and usually the behavior will change a little bit. And you see it's still not enough, so we still have one or two that are intersecting. If I set this to 100, of course it will get slower, but maybe it will also resolve these problems already. And if this doesn't help, then you have to increase the substeps anyway. So for really accurate hair simulation, substeps of 5 or something would be good. And then you can use collision passes like 30 and you should be fine. And you should not have any problems anymore with intersections. So let's take a look whether this solved it. And I think, yeah, now we are clear. And you see, without increasing the substeps, we were able to solve these problems. Okay, great. But because these are only guide hairs, so these are not the hairs that I want to render finally, it's actually not necessary that I use this small value here. So let's turn this up a little bit again, and now I can go back to my standard settings to keep this very fast. Because you see now the simulation is really fast. Actually, I do not even need to save this to disk. I will just work on like this because it's so fast. Okay, so that's it. We have created some guides that are simulated, but how can we add more hair now? So what we have to do is we have to use another hair gen. So let's create another hair generate node. And I think, let me quickly take a look. Yeah, there's one thing that I forgot up here. I could turn off the use guides up here because actually we have no guides. We are creating some guides, so I could turn this off. It really doesn't make any difference, but I think that it may calculate a little bit faster, or I don't know. But you can turn it off when you initially generate your hair guides. Right now, I will use it. So with this node, I need some guides because I want these hairs that are generated by this node to follow along my guides. And if we take a look at these inputs, you see the first one requires the rest skin. So this means we want to have the skin, and it is, in our case, this is the skin that does not move. Our circle does not move, so that's very handy. And we just take the output of our reverse node, otherwise we will get problems with our normals, and put it into our first input right here. And you see what it does now. It creates already again some hairs. Now we need some guides. And in this case, we want to have the animated guides. So we will take this one here and put it in here. And now you see there's a third input that asks for an animated skin. So we have no animated skin. We have no character that's animated. So we do not need this in our case. But you also see that it has some problems. It says that it misses a rest and rest root attribute. How can we create these? To create these, let me quickly change this layout here a bit to make this a bit more obvious. I press Shift S to shift between these, by the way. there is this rest position node that we can use. So let's take a look what this requires. It requires a deforming input and it requires a rest position. So this has to go into our guide stream. Now, where is the deformation? The deformation is coming out of this one here because this is our simulation. And where do we have a rest state? We have a rest state right here because here our hairs are not moving. So this is the rest state of our guides. So we can take this one here, plug it in here, and from this one we go into our hair generate. And if we go back now, this should now work. And you see we have no more arrows here. This rest state actually creates some skin prim and skin prim UV attributes that the hair generation wants to have. Okay, so what we can do now is, if we take a look at this right away, you see what's happening. So now I have my hairs, and right now they are already a little bit thicker, but we can go even crazier here. So let's do around 10,000 to create really crazy hair. And as you see here now, these are following along my guides now. So that's pretty cool, but it looks a little bit strange. Let's take a look how we can make this look a bit more interesting and a little bit better. First of all, there is an option in Houdini how to shade your hair inside your viewport. And what that means is, let's go up one level. Let's go to the hair simulation geometry node and to the miscellaneous settings here and activate shade open curves in viewport. And you see we get this nicely shaded look here. And that's actually quite handy, because then we can see how our hair will look later on when we are rendering these. I will just change, I could change the color actually. So maybe we will do that, add in some color in here and just colorize these hair so that they are a bit more interesting. Yeah, something like that, pink hair, very trendy. And then we can see them just a little bit better. And another thing that you see right now on the tips, these get thinner. And this is actually also created by the hair generator node. If we go to the attributes and appearance, you see we have a width attribute that is now taken into account by this shading. And this is actually running through this ramp, as you can see here. So this ramp is what's causing these to get thinner on the tip. If they are too thin, so if you want to see your guides or your hair a little bit better, you can of course come in here and make them thicker. In our case, that's not necessary. We will leave it at 0.001. Okay, so that's pretty cool, because now we have a really thick hair, as you can see here, and they are really nicely moving with our simulation. Of course, you can see that some of them are, or we can see these kind of strands, and this has to do with the resolution of your, or with the density of our initial guides. So if I increase this, let's say 500, and let's render this quickly. So I have to wait until my simulation is rendered and maybe just start it from the beginning. Let's take a look. You will see now these strands will be not that obvious anymore because we have way more guides, and you see you get a more accurate simulation. And it still is very fast, as you can see here. So let's merge quickly our rubber toy into this so that we can see that our collisions are still looking quite nice. These hairs are now not calculating any collisions. So these just follow our simulated guides, but you see it looks quite nice. So really quite natural and quite cool. And we could go even higher here. So now I am on 10,000, but we can go to 20,000. It's no problem. Now we have really, really thick hair, as you can see here. And if I add in, let me do this quickly, just add in a distant light here, so that we have something that is actually shading this a little bit, like so maybe. And we can go out of this now. Now we have just some shading going on here. Yeah, you can see this now a little bit better, and depends on what quality level we are, we even get some shadows and all that stuff. So now you can see we have really dense hair, and still all these movements are still working quite nicely. Let me actually do it like this. It looks a little bit better. Okay, so this is how you can simulate some guides and then add hairs using this hair gen. The cool thing is that Houdini has really a bunch of tools how to make this look better now. And these are these guide process nodes. So if we type in guide here, you see we have these guide process things. And these guide process things are pretty cool. Let me just use the guide process standard node in here. And we can actually just put it in here. It requires as an input the guides. And you see the guides come out here of this output. And it requires also the skin. And the skin comes out of this second output. So you can wire it up like this. Then there is this skin VDB. In case if you are working on a character, on a head or whatever, you want to create a VDB out of your base geometry to create or to calculate some collisions. We do not need this in our case because, yeah, we are not colliding with our circle, so we can just leave it off. But you see by default, what did it do? It just made everything flat. And now, yeah, this definitely is not what we want. This is because by default, the guide process is set to set direction. So if we change this and start blending this back, you see what it is doing. It is just laying them flat in whatever direction you specify. And that's not what we want. But what we want, for example, what can be pretty cool, and let me activate my color again, is to change the length. And that's also something you can do. You can set the length here. Now you could either, for example, animate this and create some growth animation with it, or you can just randomize it a little bit. And that's actually what I want to do. So 0.5 or 0.7 and 1, or let's make it even 1.2 maybe. And you see now we have nice hair that has different length. And this will also look a little bit more realistic and a little bit nicer. So this is an option that you have. That's pretty cool. Maybe not that much, something like that. Another option that you have with this guide process is you can add more of these effects. So I can just click this plus here. And instead of choosing the set direction, I can, for example, use Frizz. So Frizz is also something that can be quite interesting. Let's take a look what our Frizz is doing. And yeah, right now, I think that, let's go back here to frame number 0. Something is not quite right. And this probably has to do with, let's see. Yeah, it's the amplitude. The amplitude. Oh, this is actually a little bit strange why the Frizz is not really working. Let's try something else. So let's turn this off and let's put in another guide process. A separate guide process here. So let's put this in here. Let's see whether this will work a little bit better. Yeah, right now it works. You see, we do not get these artifacts. So what the Frizz does by default is, if we turn it off, you see, it just adds some noise along these hairs. And if we take a look at this now, this will look, again, a little bit more natural and a little bit nicer. You can come in here and change the frequency. So the lower you turn this, the bigger this Frizz will get. And it, of course, depends a lot on how much subdivisions and points you have on your hair. Let's set it to 25 for now. And then you have this amplitude. And the higher you set this, the more extreme, of course, this Frizz gets, as you can see here. So we don't want to do that. We want to keep this quite low. And then you can also do some random amplitudes, maybe for 0.2, and random frequency, maybe like 15. And you will get something like this. And I think the amplitude 0.02, I should say, otherwise it's way too high. Yeah, we get something like this. And this could now look also quite nice. So these are just a few basic operations that you can do after creating your simulation. And if you save the simulation to disk, which I did not do, then this, of course, will get a little bit faster. There's one problem now that you can see here. Some of these are not following along anymore. And if this happens, what you usually want to do to correct this, you want to go to your hair gen. And here is this influence radius for your guides. And if you increase this, let's see whether this will already fix it. Yeah, you see, I just increased it a tiny bit and it already fixes these problems. So if you have these problems that some of them are not moving with your simulation, then just come in here and increase the influence radius. And now you see what we have here. We have a very nice simulation of very dense hair with our rubber toy running through this. Now you can render this hair depending on what renderer you use. So with Redshift and Mantra and also with Karma, I think you can render these directly without even adding in any geometry. But of course, if you want, you can, as I showed you before, add some sweep or add a Polywire and create some geometry around these. Okay, so this is it with this tutorial. If you want to get this project file, then jump over to Patreon, there you can download it for free. If you want to learn more about Vellum Hair or about Vellum in general and Houdini, then check out my course, the Vellum Playground. And yeah, thank you very much for your support. Thank you very much for watching, and I really hope to see you soon. Goodbye.